A particle moves in a straight line such that its displacement x meters from a fixed origin at time t seconds is modeled by this. Identify its initial position. Now we have this again. We have a displacement time. Now displacement is just very similar to the distance. Displacement is almost the same as distance. For the physics students, you know that is a displacement is a vector, distance is a scalar, but it comes down to the same thing for the math students. Okay, what we're looking at is the following. This is x and this is t because it's how the distance that x is at a certain time from the origin 0. And the distance that it is according to this equation, t squared minus 6t. So it's not how far is it from there to there. We plot how far the thing is and then the graph is drawn according to that. So identify its initial position. So on my graph, the initial position for A, the initial position is where the distance or when time is 0. Initially, time equals 0. And when time was 0, what was x? The distance x, because the x is the displacement, how far was it away, equals 0 squared minus 6 times 0 plus 1. So the answer is 1. So at the start, it was positive 1. What is x? X is the displacement. So positive 1 means it's to the right. So the question was identify its initial position. So the initial position is 1 meter to the right of the origin. Now in B, it gets a little bit more complicated, or not really. They say after t seconds, and I put t seconds because we don't know specifically where it is, the particle is momentary at rest. Now, when it's at rest, it means it's not moving, but it is a certain distance away. And when we look at momentary at rest, it means the thing is moving and then it stops. Now, if you can remember the change of displacement in terms of time, the change in displacement over the change in time is nothing else but your velocity. Displacement is with velocity. Remember, if I use distance, then that will be speed. Just the same thing. So what they say is when it comes to rest, it means the velocity is 0. If the velocity is 0, it means that is when my derivative equals 0. So let's find the derivative. Velocity equals dx dt, and dx dt equals 2 goes to the front, it's 2t minus 6, and the 1 falls away. So that is the velocity. Where's the velocity 0? What's the time when this comes to rest? So when this comes to rest, therefore, t equals minus 6 goes over, it becomes plus 6, and then I divide by 2, so that will happen after 3 seconds. Okay, so calculate t, we've done that. The position of the particle at this time. So we know the time is 3 seconds. What is the position? The position is going back to x. So they ask us what is x when the time is 3 seconds. And I'm just going to substitute 3 in there. It's going to be 3 squared minus 6 times 3 plus 1. That's 9. 9 take away 18 plus 1. And that answer is negative 8. What is the position? Negative 8 means that it is 8 meters to the left of the origin. Now, what's the average speed over the first t seconds? Now, we know, doesn't matter how this graph look like, I know that the moment we look at average, the average equals the change x2 minus x1. Okay, so when x is 3, y is minus x, so we have minus 8 take away. Initially, it was when x is 1, divide by 3 minus 0. Because that's my x, that's my t. So I'm just going to change it. It's just confusing with the x's. So yt means it is x2 minus x1 divided by t2 minus t1 according to our graph here, which is this minus 8 minus 1. That is minus 9 divided by 3, and that gives us 3 meters per second. 3 meters per second. It's actually 0. That is 3 meters per second. That is the average. Minus 8 take away 1, 3 take away 0. So this is minus 3 meters per second. That will be the average speed of the particle over the first t seconds.